Hello everyone and welcome back to the channel. So if you don't already know, I was a world topper in IGCSE Ad Maths. So now I'm going to be creating more videos on that, and of course I'll also be continuing with extended maths 0580. But for today's video I wanted to focus on a very important topic in Ad Maths, which is differentiation as part of the calculus topic. So from IG you should already know your basic differentiation rules. For example, if you have a term x to the power of n, the derivative of that is nx n to the power of n minus 1. Nx to the power of n minus 1. So if you're a little unsure about these, you can always go back and watch my videos on the 0580 differentiation course. But today I'll be going through some differentiating special functions that are tested in Ad Maths. So the first one, that's the most prominent one that comes to mind, is e to the power of x, which is the exponential function. And this actually has a very nice derivative, which is the same. It remains as e to the power of x. So that's an easy one to remember. And now if we think of the inverse of the exponential function, the inverse is the natural log, ln. So if we have a function ln of x, natural log of x, the derivative is 1 over x. 1 over x. So those two are the inverses of each other, ex and natural log of x. And now if you think about differentiating trigonometric functions, if we start with sine x, the derivative of this is cosine x. And now if you think about finding the derivative of cosine x, it's equal to negative sine x. So one way I like to remember this is using the acronym SC, negative S, negative C. And the way this works is, if we're differentiating, we're always going down this acronym. And if we're integrating, we're going up the acronym. So I'll make a video on integration soon. But for now, let's focus on differentiating. So it's going down the acronym. So what I mean by down the acronym is, if we want to differentiate sine, we move one space down. So we get cosine x. And then if we want to differentiate cosine x, we move one space down again, which is negative sine x. And in that way, if we want to differentiate negative sine x, of course, from your IG you should know, if you just have a negative, the constant stays there, so negative 1. So if we have negative sine, that differentiates to negative cosine. And finally, if we have negative cosine, and now we have nothing below it, so we go right back up to the top like this. So this is kind of like a cycle. So negative cosine differentiates to sine x. Yeah, so that's how you would remember the rule for differentiate sine and cosine. And now if we talk about differentiating tan x, the derivative of tan x is actually secant squared x. So if you're unfamiliar with secant, what it basically is 1 over cosine x. Secant x is equal to 1 over cosine x. So secant squared x is equal to 1 divided by cosine squared x. So that's what it is. And I'll make another video, separate video on trigonometry, and where we go through the other functions that we're introduced to, like secant and cotangent. So I'll make a different video on that. But for now, these are the rules that you need to know for differentiation of the ones for Ad Maths. So now you might be thinking, how about if we have a constant in front of the x within the function. So for example, e to the power of ax. The way we do this is by using something known as the chain rule. So there's a simple way to know it, which is if we have an a in front of the x for the exponential function, you just differentiate the power, so ax, and you bring it to the front and then leave the function up there as the same. So for example, if we had e to the power of 5x, we differentiate this function, this top function, which gives us 5, and then we bring the 5 down, so that gives us 5e to the power of 5x, and we keep the initial function there. So now we can also extend this to more complex versions. So for example, if we had e to the power of, let's say, 4x squared plus 5x, you do the same thing as always. You differentiate the top. That gives us 8x plus 5. This whole thing is and then you multiply the entire thing by the original function. So this would be the derivative of this. So there's actually a general formula for this, or general form, which is if we have e to the power of any function of x, the derivative of that is equal to f of x differentiated multiplied by e times the to the power of the original function. So we're just differentiating f of x and pulling it down and leaving everything else the same. You see, everything else remains the same. So that's how you would differentiate e to the power of a function of x. So for example, if we had e to the power of sine x, we know from above here that the derivative of sine x is cosine x. So the derivative of this would be cosine x multiplied by e to the power of sine x. And that's how it would work. And this chain rule can actually be applied for any of these. So if we move on to the next case, which is natural log of x, if we had, let's say, ln of ax plus b, the derivative of this is equal to, so we know that derivative of natural log of x is just 1 over x. So using the chain rule, we just have to multiply 1 over x by the derivative of ax plus b. So ax plus b, the derivative of that is just a. So it'd be a multiplied by the derivative of ln of x as a whole, so which is just 1 over ax plus b. So you get an answer of a over divided by ax plus b. So if we go to an example, let's say we wanted to differentiate ln of 5x. Now you'll see that there's actually a very nice pattern that we come across. So what we first do is we take the derivative of the function inside, which is 5x, and the derivative of that is 5. So 5, and then multiplied by what you do with any derivative of ln x, which is just the reciprocal of x. So for this case, since we have 5x inside, it's just the reciprocal of that, 1 over 5x. And then this simplifies down to 1 over x. So in fact, ln kx, the derivative of that, remains as 1 over x. There's actually no change. So that's a very neat rule that we come across. However, let's modify this a bit, and let's say that we have ln of 5x squared plus 4. So now the way we do this is, again, we differentiate the inner function, 5x plus 4, which is that differentiates to 10x. And then we just multiply that by the reciprocal of the inner function, which is what we do for any ln function. And then, so that would be our derivative. So in general, the derivative of ln of f of x. So in general, the natural log of any function differentiates to give us the derivative of the inner function divided by the original function. And that's a very neat rule. It's something that's also easy to remember. So that's what we have for natural log. Now you might be wondering, why does this work? We can actually formalize this using the chain rule. So say we have, let's use this example, ln of 5x plus 4. The way the chain rule works is that we use a substitution. So let u equal to 5x plus 4. So now this function becomes ln of u. And the chain rule states that dy by dx is equal to dy by du multiplied by du over dx. And the way you can think about this is, because it's not entirely true mathematically, but it helps to remember it as the du's cancel out and we're left with the dy by dx. So in this case, if we want to find dy by dx, we first find dy by du, which we know y is equal to ln of u, and we know the derivative of that is equal to 1 over u. So therefore dy by du equals 1 over u, as we saw from our table above here. And then now we have to multiply that by du by dx, which is the same as just differentiating this part, and that gives us 10x. So now we multiply these two together. So dy by du is 1 over u, and then multiplied by du by dx, which is 10x, and we get 10x over u. But we're not done here, because we've set u equal to 5x plus 4. So we substitute that back into this, and we get that dy by dx is equal to 10x divided by 5x plus 4. And that's why this general rule works. That's basically the chain rule formalized. And in fact, you can apply this to any of these functions that we will discuss. So if we relate it to the example e to the power of 5, let's say e to the power of 4x squared plus 5x. If we apply the same thing and we let u equal to the inner function 4x squared plus 5x. So now y equals to e to the power of u, and now dy by dx equals to dy by du multiplied by du by dx. dy by du is the derivative of y equals e to the power of u, which is, as we know from rules, the same. It remains e to the power of u. And then du by dx, 4x squared plus 5x, that's just the derivative of that, which gives us 8x plus 5. And then one final thing to do is to substitute the u back into our equation. And so we find that dy by dx is equal to e to the power of 4x squared plus 5x times by 8x plus 5. And that's why the rule works here. So again, it's a very good thing to remember the proof of why each of these works. And so because this will help you actually understand the content rather than just memorizing these rules. And we can actually apply the same thing for the trigonometric functions. So let's say that we want to find, let's say y equals to sine of 5x squared plus, let's say 6x cubed plus 4x. We want to find dy by dx. Now how do we do this? Again, we can use the chain rule. We can let u equal to this inner function, like what is in place of the x. So u is equal to 6x cubed plus 4x. And now from our chain rule, we know that dy by dx equals to dy by du multiplied by du by dx. So dy by du, so we substitute this into here. So now we know that y is equal to sine of u. So dy by du is just cosine of u, as we know from our table above. So this is equal to cosine of u. And now du by dx is just the derivative of this, where u is the subject. So that gives us 18x squared plus 4. And remember to have these brackets around to ensure that you're multiplying the entire thing by the previous term. It's a very common mistake I've seen students make. And now one final step is to substitute back in our u into our derivative. So we get cosine of 6x cubed plus 4x multiplied by 18x squared plus 4. And that is equal to dy by dx for this function. And so that's the general rule that we do for each of these trigonometric functions. And that's just how you'd find it. So now here are some questions that I want you to try. Number 1, if y is equal to cosine of 4x squared plus 6, find dy by dx. So the general question here is just to find dy by dx for each of the following. Let me write this again. So find dy by dx. So for question 1, and I want you guys to put your answers in the comments below. So if y is equal to cosine of 4x squared plus 6, that's the first question. Number 2, if y is equal to 4 multiplied by ln of 5x, differentiate that. And remember, if you have a constant in front of a function, you can treat the constant separately. So what you basically do is you differentiate ln 5x first, and then just multiply that by 4. So yeah, what you do is just differentiate this first and then just times by 4. Number 3 is to find the derivative of y is equal to tan of 4x. And number 4 is y is equal to 3 sine 4x minus cosine of 2x minus 3. And number 4 is actually, it looks daunting. However, remember that if you have two terms added in an expression like this, you can always treat them separately. And so first differentiate the first term, and then differentiate the second term, and then you can add them back together. So that's what you would do for this final question. And this is the kind of differentiation that you'd be expected to do for an A-star student in this course. So yeah, those are all the questions for you. Put down your answers in the comments below, and stay tuned, subscribe where my next video I'll go deeper into differentiation, where we learn about the product rule and the quotient rule. So today was just a basic introduction and use of the chain rule. So if this is helpful, please like, share, and subscribe. And I'll see you guys in the next video. Bye.